Okay, welcome once again. So we want to look at the 2017 Jamb question. So we'll look at the questions and then we'll try to provide solutions. First, we'll start with providing an answer, then explaining why the option that we chose was chosen. And on your part, as we go along, please ensure that you are also participating. I will always be telling you to put your own answer in the comment section before we review my own answer. So please ensure you're participating. Don't just wait for the answer to come and then you will not engage the questions yourself because you know the answer will definitely be supplied. So please participate as much as you can. Okay, let's start off with the first question now. The general formula of alkanones is alkanone is also referred to as ketones. The general formula of alkanones is it RCHO, RCOR prime, RCOOH, or RCOOR? So please let me know, share with me what you feel the right answer is in the comment section. Okay. The answer to this is actually option B, RCOR prime. That's the general formula of alkanones. Alkanone, also called ketones, are organic compounds containing a carbonyl group bonded to two acyl groups. That's the R and the R prime. The general formula is RCOR prime, where both R and R prime can be the same or different acyl groups, as the case may be. So that's that for that. So let's move on to the next one. The constituent common to duralumin and honeycomb is it cobalt? Is it manganese? Is it aluminium or magnesium? Okay, so the right answer to this one is option C, which is aluminium. Aluminium is the common constituent. And duralumin is an alloy composed primarily of aluminium with copper, manganese, and magnesium. Alnico is an alloy containing aluminium, nickel, and cobalt. So the common elements is aluminium, Al. Okay. The third question says that the shape of the s orbital is A, elliptical, B, spiral, C, circular, D, spherical. So the shape is D is the right option. It's spherical, and the s orbital in atomic structure is spherically symmetric around the nucleus. This means the probability of finding an electron at a particular distance from the nucleus is the same in all directions. It differs from the p orbitals and which are dumbbell shaped, you know. So it is spherical. Okay. On to the next one. The fourth question says that aluminum hydroxide is used in the dyeing industry as A dye, B dispersant, C salt, D mordant. The answer there is mordant. And basically in the dyeing industry, a mordant is a substance used to fix dyes on fabrics. Aluminum hydroxide acts as a mordant by forming a complex with the dye, which then binds more effectively to the textile fibers. This enhances the color fastness, the ability to color to get to be, fixed on the material, meaning the dye adheres more effectively and is less prone to washing or fading. Okay, so that's that. Okay, the fifth one says that the tincture of iodine means iodine dissolved in what? The tincture of iodine means what? Iodine dissolved in A, ethanol, B, bromine chloride, C, chlorine water, D, water. The answer or the right answer to this one is ethanol, A, option A. And tincture of iodine is a solution of iodine or in ethanol, that's alcohol. Sometimes with a bit of potassium iodide. It is commonly used as an antiseptic. Iodine does not dissolve well in water, but it dissolves readily in ethanol, making ethanol the correct answer. Okay. The next one says that temporary hard water is formed when rainwater containing dissolved carbon dioxide flows over deposits of calcium carbonate, sodium carbonate, sodium sulfate, calcium sulfate. So, what is the right answer here? Is it A, is it B, C, or D? Let me know in the comment section what you feel the right answer is. Okay. And the correct answer is A, calcium carbonates. Okay. Calcium carbonate. So basically, temporary hard water is caused by the presence of calcium hydrogen carbonate, which forms when carbon dioxide in rainwater reacts with calcium carbonate in limestone deposits. So the reaction is what we can see there. CO2 plus water will give us carbonic acid. And then the carbonic acid will react with calcium carbonate, and then gives us calcium hydrogen carbonate. Now, this calcium hydrogen carbonate is soluble in water and causes temporary hardness, which can be removed by boiling. So Na2CO3 and Na2SO4 are soluble sodium salt and do not cause hardness. Calcium sulfate causes permanent hardness and not temporary hardness. So we eliminate those ones, and the right answer is calcium carbonate. Okay. The next one says that the acid anhydride will produce weak acid in water. Sorry, the acid anhydride that will produce weak acid in water is it SO3? Is it NO2, SO2, or CO2? So the right answer here is CO2. Because when CO2, which is an acid anhydride, dissolves in water, it forms carbonic acid, H2CO3, which is a weak acid. The reaction is what we can see below, CO2 plus H2O to give us H2CO3. Okay, the process that occurs when two equivalent form of a compounds are in equilibrium is it isotopy, resonance, isomerism, or reforming? The right answer here is resonance. Resonance occurs when a molecule of ion can be represented by two or more valid Lewis structure called resonance structure or canonical forms that differ only in the position of electrons, not atoms. These structures are not actual isomers, but rather depict the delocalization of electrons within the molecule. The real structure is a hybrid of all possible resonance forms and has greater stability. So that's that for that. So example include benzene, which has alternating double bond, which shows resonance. Carbonate ion, CO3 2 minus, the double bond is delocalized over three oxygen atom. Okay. So we move now to the next question, which is in the laboratory preparation of ethyl ethanoate, the water present in the mixture is removed using A, anhydrous calcium chloride, B, concentrated NaCO4, dilute NaOH, and concentrated H2SO4. The right answer is concentrated H2SO4. And that is what we use to remove water, concentrated H2SO4. So in a esterification reaction like the formation of ethyl ethanoate from ethanol and ethanoic acid, water is formed as a byproduct. To drive the equilibrium towards ester formation, this water must be removed. Concentrated sulfuric acid, H2SO4, acts as a dehydrating agent, removing water from the system and thus shifting the equilibrium to favor more ester formation according to Le Chatelier's principle. So concentrated H2SO4 is what we use in the lab to remove the water that is present. Okay. The constituents of air necessary in the roasting process are oxygen and water, argon and carbon dioxide, CO2 and H2O, and oxygen and carbon dioxide. And the answer here should be A, oxygen and water. So roasting is the corrosion of iron in the presence of oxygen from air and water, H2O from the humidity or liquid. Okay. For a general equation of the nature xp plus yq mr to give us mr plus ns, the expression for the equilibrium constants is it A, is it B, is it C, or D? The suitable expression is actually C. And the reason is because for a general reversible reaction, Sp plus yq to give us mr plus ns like that, the expression for the equilibrium constant K equilibrium is R raised to power M S concentration of S raised to power N concentration of P raised to the power X and the concentration of Q raised to the power Y. Basically, PQRS are the equilibrium concentration of the reactants and products. SYMN are the stoichiometric coefficient from the balanced chemical equation. Thus, option C correctly represents the equilibrium constant expression. Okay. All right. So this one says that a given mass of gas occupies 2 dm cube at 300 Kelvin. At what temperature will its volume be doubled, keeping the pressure constant? Is it at 400 Kelvin, 480 Kelvin, 550 Kelvin, or 600 Kelvin? The answer is 600 Kelvin. And to solve this, we use Charles' law, which says that V1 over T1 equals to V2 over T2. Given that the initial volume V1 is 2 dm cube, the final volume V2 is 2 multiplied by 2, which is 4 dm cube, because he said if the volume was doubled, okay? So the initial temperature T1 is 300 Kelvin as given, and then the final temperature is what is unknown. Okay, I haven't said that we apply Charles' law, V1 over T1 equals to V2 over T2. And when you cross multiply, you get the unknown how. So your 2T2 will be equals to 4 times 300, which comes to 1,200. So your T2 will be 1,200 divided by 2, which is equals to 600 Kelvin, 600 Kelvin. Okay, so let's take note of that. So 600 Kelvin is what we got. Right, see, just a minute. I want to do something. I want to check something. Okay. Oh, pardon me. I'll go back. Okay, the next question here says that, okay, I think I've solved this. Solved this. I've shown the working of this one. Okay. So the next question is the 13th question that says that the oxidation number of iodine in KiO3 is it plus 7, plus 3, plus 5, or plus 6? We'll work it out now. The answer is plus 5. And how do we arrive at that? Assign the known oxidation number. Potassium in an alkali metal has an oxidation number of plus 1. Oxygen in most compounds, except for peroxide and superoxide, has an what's it called? Oxidation number of minus 2. Now let the oxidation number of iodine, I, be X. If that is the case, we can say that K plus 1, so K plus 1, okay, yes, potassium plus X, which is standing for iodine, then 3 times minus 2 for oxygen. So that'll be plus 1 plus X plus 3 times minus 2, which is equals to 0. That'll be plus 1 plus X minus 6 equals to 0. X minus 5, because plus 1 minus 6 is minus 5. X minus 5 equals to 0, so X will be equals to what? Plus 5. Excuse me, please. Okay. The isomer of pentane, that's C5H12, is 2-ethylbutane, butane, 2-methylbutane, 2-methylpropane. So the isomer is C, 2-methylbutane. And why did we choose that? To identify an isomer of C5H12, that's pentane, we must look for the compound that have the same molecular formula of C5H12, but different structures. So when you look at it, the three isomers for pentane are N-pentane, which is straight chain, 2-methylbutane branch at C2, that is at carbon 2, and then 3-methylbutane. 3-methylbutane, that is same as 2-methylbutane due to symmetry. No, 2-methylbutane is the correct IUPAC name. So it is 2-methylbutane, that is the isomer of C5H12, which is pentane. Okay. When few drops of concentrated triazonitrate 5 acid is added to an unknown sample and weighed, an intense yellow coloration is observed. The likely functional group present in the sample is it option A, option B, option C, or option D? Okay, so the likely one is actually option A. And why did we choose that? When a few drop of concentrated triazonitrate 5 acid, HNO3 are added to an unknown compound, and the mixture is warmed, an intense yellow coloration indicates the presence of primary aromatic amine or amino acid group. Now, this test is known as the xanthoprotic test, and which is used to identify aromatic amino compounds such as phenylalanine, triosine, tryptophan, and so on and so forth that contains benzene ring with amino or hydroxyl group. However, even aliphatic alpha amino acid can give a yellow coloration under certain strong nitrating condition due to reaction with the amine group. Okay, so the right option there is A, and then the reason stated has been explained. Okay. All righty. So we move on now. A sample of orange juice is found to have a pH of 3.80. What is the concentration of the hydroxide ion in the juice? Is it option A? Is it option B, option C, or option D? We need to do a little calculation by looking at the negative logarithm of, pH equals to negative logarithm of the hydrogen ion concentration or hydroxide ion concentration as the case may be. So if you look at that and you use that formula, you end up having the right option to be B, which is 6.3 times 10 raised to the power minus 11. Now, how did we arrive at this? Like I said before, okay, don't forget that our pH plus pOH equals to 14, So when you bring the pH and you add the pOH together, you must have 14. That is statutory. It has been stated and we know that. Now the pH of 3.80 means that the pOH will be what? 14 minus 3.80, which we end up having a pOH of 10.20. A pOH of 10.20. But that is not what we are looking for. What we are looking for is the concentration of the hydroxide ion in the juice. But don't we are almost there because we have found that the pOH is 10.20 by subtracting 3.80 from 14. Okay, I haven't said that. It means that our pOH, our hydroxide ion concentration is just the anti-logarithm of what we have as our pOH. So it's just like, so when you do the anti-logarithm of 10.20, you end up having an hydroxyl higher concentration of 6.3 times 10 raised to the power minus 11 mole per liter. Okay, so that's how we arrive at that. Incomplete oxidation of ethanol yields what? Is it ethanoic acid? Is it methyl sorry. Is this CH3COCO3 or CH3CH2OCH2? That's ethyl ethanoate, or is it the aldehyde ethanal? Is it the aldehyde ethanal, or is it the ketone that we have there, the ketone propanone? Now, it will give us the answer is CH3CH2. When there's an incomplete oxidation of ethanol, it will end up giving us an aldehyde, which is the ethanal now. So basically what happened is that ethanol can undergo oxidation depending on the extent of the reaction. Now, for an incomplete or partial oxidation, your ethanol will transit from being ethanol to become what? To an aldehyde, which is what? Ethanal. Now, so the product is ethanol, which is an aldehyde. Now, this is an incomplete oxidation, typically using a mild oxidizing agent like acidified K2, Cr2O7 under controlled condition. For a complete oxidation, you will end up having what? Ethanoic acid, for a complete oxidation. So let's take note of that. The salt formed from a weak acid and a strong base hydrolyzes in water to form what? A saturated solution, an acidic solution, a buffer solution, an alkaline solution. The answer to these is actually an alkaline solution. An alkaline solution. And the reason is when a salt is formed from the neutralization of a weak acid and a strong base, it undergoes hydrolysis in water and the resulting solution is alkaline in nature. A very good example is when we have sodium ethanoate formed from ethanoic acid and sodium hydroxide. When it hydrolyzes in water, it will give us that. And then the acetate ion, that's the CH3COO minus, hydrolyzes to produce an hydroxide ion This causes the solution to become basic or alkaline in nature. So the ideal gas law and equations are true for all gases at A, low pressure and low temperature and high pressure and high temperature, low pressure and high temperature. So the answer is low pressure and high temperature. Now the reason is because the ideal gas law, PV equals to nRT, assumes that gas particles have negligible volume. There are no intermolecular forces between particles, and also collisions are perfectly elastic. Now, these assumptions are mostly accurate under low pressure. So particles are far apart and volume is negligible. High temperature. So kinetic energy is high and intermolecular forces are insignificant. Okay, so please, let's take note of that. When delta H is negative, a reaction is said to be A, endothermic, B, exothermic, C, reversible, D, ionic. So when delta H is negative, the reaction is said to be exothermic. And then delta H represents the enthalpy change of the reaction. When delta H is less than zero, that is negative, it is released to the surrounding. The reaction is exothermic. When delta H is greater than zero, which is positive, it is absorbed from the surrounding. The reaction is endothermic. Okay. When you have that radiation, equation, as you can see there, plus alpha particle, and then you are being asked that what is that what's it called? The value for x. The value for x is very simple. Don't forget that we are having 226, 88 random moving to x 86 random like that. So the missing link there is this, is can be gotten because we know that our alpha particle is 4 2 helium atom. So it means that when we apply the conservation of law of apply conservation law, which says that atom can neither be created nor destroyed. So the mass number, from the mass number, you know that 226 equals to x plus 4, Therefore, my x is just 226 minus 4, and that gives you 222. So the atomic number, 88, is 86 plus 2, 88, which equals to 86 plus 2, 88, which equals 86 plus 2. So we must take note of that. So very, very important. So that's just two difference between the atomic number. The shape of ammonia molecule is triangular pyramidal, octahedral, square planar, or tetrahedral. The answer is triangular pyramidal, or pyramidal, or pyramidal. I think pyramidal is the right word. Now, the reason is because three bonding pairs of electrons with hydrogen atoms. It has one lone pair of electron with the nitrogen atom. So the electron pairs arrange themselves tetrahedrally to minimize repulsion, as per VSEPR theory. But because of one of the position is occupied by a lone pair, the actual molecular shape is trigonal pyramidal. So let's take note of that. The mass of silver deposited when current of 10 amperes is passed through a solution of silver salt for 4,830 seconds is, okay, is it A, B, C, or D? Now, when you go through the calculation, you should end up having 54 grams as the mass. And to calculate the mass of silver deposited during electrolysis, we use Faraday's first law of electrolysis. And from that first law of electrolysis, we say mass equals to current multiplied by time, then divided by the number of moles in the Faraday constant. So when you do that, our current is 10 amperes, our time is 4,830 seconds. Our M is the molar mass of silver, which is 108 gram per mole. Our N is number of electron transferred per silver ion, which is like 1. And then our Faraday constant is 96,000 coulombs per mole. So once we bring in the values, we substitute the values, what we end up having is 54.04, and that's the answer. Tin is unaffected by air at ordinary temperature due to its low melting point, weak electropositive character, high boiling point, white lustrous appearance. So why is tin unaffected by air at ordinary temperature? The reason is because of the weak electropositive character, the weak electropositive character. Tin is unreactive in air at ordinary temperature, primarily because of its low reactivity or weak electropositive character. This means it does not readily lose electron to form oxides under normal condition. That means that tin is a post-transition metal, and its atoms are less willing to oxidize compared to more reactive metals like sodium or magnesium. So we must take note of that. Then it may also form it may also slowly form a tin protective oxide layer. But this layer prevents further oxidation, making the metal appear inert in air at room temperature. Okay. So the next one says calculate the amount in moles of silver deposited when 96,500 coulombs of electricity is passed through a solution of silver salt. So the options are there. And the answer to this one is 0.1 mole. And the reason why we chose that is because the formula is mole of silver equals to the quantity of electricity deposited over the number of the electrons times the Faraday constant. So where Q is the charge in coulombs, which is 99,650. Faraday constant is 96,500. Number of electrons required to deposit 1 mole of silver equals to 1, since Ag plus 1 electron equals to silver, which is deposited. So when you substitute this value, you end up having 0.1 mole, which is the answer there. The next one says that the reaction of halogen with alkanes in the presence of sunlight is an example of an oxidation reaction, addition reaction, hydrogenation reaction, or substitution reaction. This is a classical example of a substitution reaction. And we can see it playing out there. So in the presence of sunlight, light through a free radical substitution mechanism. So you have something of this nation. So that is it's a substitution reaction. The enzyme used in the hydrolysis of starch to destrain and maltose is it lipase, is it amylase, is it invertase, or zmase? The answer is actually B, amylase. And that's the explanation is as a result of that. Amylase is the enzyme responsible for hydrolysis of starch, which is a polysaccharide, into destrains and maltose, which are disaccharides. It acts by breaking the alpha 1,4 glycosidic bonds in starch. So there are two main types. We have the salivary amylase that we call ptyalin. This one is in our mouth, and it acts on starch or starchy food in our mouth. Then we have the pancreatic amylase, which acts in the small intestine. The same function too. So the acyl group is represented by the general formula CN H2N CN H2N minus 2, Cn H2N plus 1, and Cn H2N plus 2. Don't forget that the acyl group is just is gotten from alkane. And alkane has a general formula of CnH2n plus 2. But the acyl group is different from alkane in the fact that they have one hydrogen short of what we have in alkane. So when you have methane, which is like a CH4, a methyl group or a methyl group is CH3 less than 1. So based on this, you can actually know that the acyl group general formula should be like CnH2n plus 1. So less than 1 hydrogen. That's that for that. Okay. So just like what I explained. So that's just what the explanation is there. The next one is copper disulfide plus oxygen to give us copper and then SO2. What is the change in the oxidation number of copper in the reaction? Is it 0 to plus 2, 0 to plus 1, plus 1 to 0, or plus 2 to 1? If you look at the transition, you look at it that the answer is plus 1 to 0. So it's moving from copper 1, then give us elemental copper. And then you can actually look at it there. Copper sulfide has an oxidation number of -2, or the sulfide ion has an oxidation number of -2. Since the formula is Cu2s, two copper atom must be balance the -2 from sulfur. Therefore, each copper is +1 in Cu2s. So copper, which is the on the product side, elemental copper in its metallic form has an oxidation number of 0. So it is a transition from +1 to 0. So the change in the oxidation number is from +1 in Cu2s to 0 in copper metal. This means copper is reduced as its oxidation number decreases. Okay. So the 30th question says in the diagram above, is it SO3, SO2, sulfur, or H2S? Now, S is actually SO2, sulfur dioxide. And the reason is because if you look at it carefully, sorry, let me take this off here. If you look at it carefully, you see that from the setup shown in the diagram, this is a typical laboratory preparation of a gas collected by downward displacement of air. That is, gas jar not inverted, meaning the gas is denser than air and not highly soluble in water. Now, what are the observations that we can bring out from the diagram? A round bottom flask is heated. This is likely generating a gas. Now, the gas travels through a delivery tube into a flask labeled Y, possibly a drying agent or reaction medium. Then into X for collection. X is a gas jar used to collect the gas. Okay, so it is used in collecting the gas. So now the common setup for sulfur dioxide preparation, the gas SO2 is commonly prepared by reacting Na2SO3 plus H2SO4. Then it gives us, SO2. Now the gas evolved, which is SO2, is denser than air, and it is slightly soluble in water and collected by a downward displacement of air, just like what we have in the diagram. Okay, so now Y is placed in the part of the gas before. Oh, sorry, it looks similar. Oh, it's almost similar. But this is another question. Okay, I was thinking I was explaining the same question. So we are done with that one. So we are looking at another one that says that the diagram above Y is what? Is it fused calcium oxide, H2O, sodium hydroxide, or concentrated H2SO4? And we say the answer is fused calcium oxide. And the reason is because Y is placed in the part of the gas before it gets to the collection jar. That means its role is likely to dry the gas, that is, remove moisture without reacting with the gas, SO2. Okay, so that's that for that. Calculate the mass of copper deposited when a current of 0.5 ampere was passed through a solution of copper 2 chloride for 45 minutes in an electrolytic cell. So we're given those, parameters. The Faraday constant is that, and the relative atomic mass of copper is 64. So the answer to this one is actually A, 0.448 grams. And how did we arrive at this? Using the Faraday first law of electrolysis, we can calculate the mass using that formula. Then we have these parameters that has been given to us, so we can bring them out one after the other. Don't forget that you don't use 45 minutes like that, but you have to convert it to seconds. So we convert the 45 minutes to seconds, and then we have 2,700 seconds, okay? I haven't got that. You can now plug in the values. Now, when you plug in the value, you end up having a mass of 0.4477 gram, approximately. Points